The wave mill. The wave mill is an ocean wave energy converter, which works quietly and does not have moving parts. The wave mill design is simple. The wave mill is a long line of rigidly joined open chambers. Each chamber has inlet and outlet flap. All chambers connected to inlet and outlet air ducts. An air turbine located between ducts always receives unidirectional airflow and generates power. How the wave mill works. The design is based on a concept of reciprocating air pump. Oscillating water inside an open chamber plays role of piston. When water rises up, water pushes air out via outlet flap. A falling water creates a low pressure inside a chamber and air comes in from the inlet duct. When wave crest is passing along a wave mill unit, wave crest creates an oscillating water motion inside chambers. Oscillated water pushes air out and pulls air back. The unidirectional, uninterruptible, continuous airflow is the best way of feeding air turbine and significant wave mill advantage. Out tests demonstrated that even 10 cm waves create stable airflow inside air ducts. The wave mill prototyping. Our team built 3-meter-long prototype and performed pool and river tests. After that we built a few more lab prototypes and tested them in the wave flume of the University of Queensland. Professor Peter Nielsen and his team performed own tests.
Hello Peter, good morning.
Good morning. Nice to do some real experiments now.
Yeah. And today we could achieve very good result. Today we made first electrical power output measurements.
First power readings, and they're very encouraging.
We tested prototypes for power generation and wave attenuation. We learned that the wave mill generates power in a wide range of wave conditions and perfectly attenuates waves. We built the full-scale prototype. The prototype is 30 meter long, 1.5 meter wide and 1.5 meter high. We ran trials in the Moreton Bay. The wave mill demonstrated stable performance. The power output correlated with the wave input. The recorded 36% efficiency from wave-to-wire proves that the wave mill can generate commercially valuable power and compete conventional power plants. The wave mill unit's output depends on two major parameters: wave input and unit's width. The wave input measure unit is kilowatt per meter. That means wider unit has larger generating capacity. The output stability depends on the unit length. The wave mill generates power when at least one wave crest is passing along. To maintain stable power output, the unit's length has to be longer than average wavelength in the mooring location. Wave mill applications. For customer, the wave mill is a large floating platform with embedded power supply. The combination of the continuous uninterruptible power supply and the large flat deck creates a perfect foundation for a wide range of customer applications. Generated power can be used on board or sent to the land grid. The wave mill applications which send power to the land grid. Power supply for islands and close to shore communities. Floating breakwater and marina. Coastal protection. The wave mill applications which use power on board. Green hydrogen production. Floating support facility for offshore industry. mariculture, fish cages, oyster farms. Tourism and recreational purposes, artificial reef, diving platforms, botels. Wave mill market. The world's electricity consumption has continuously grown over the past half a century, reaching approximately 26,000 terawatt-hours in the last year. The theoretical potential of wave energy is 30,000 terawatts-hour and can mainly be found between 30° and 60° latitude and in deep water locations. Locations with the most potential for wave power include the western seaboard of Europe, the northern coast of the UK, and the Pacific coastlines of North and South America, Southern Africa, Australia, and New Zealand. The North and South temperate zones have the best sites for capturing wave power. The National Renewable Energy Laboratory estimated the theoretical wave energy potential for various countries. It estimated that the U.S. potential was equivalent to 1170 terawatts-hour per year, or almost 35% of the country's electricity consumption. The Alaska coastline accounted for 50% of the total. Wave mill commercialization. Why the wave mill compete conventional power plants? The wave mill design is simple, modular and easy to scale. Low capital and operational expenditures allow to keep the cost of electricity less or equal to the main grid. The wave mill uses only off-the-shelf materials. To reduce the cost of fabrication, we uniformed all parts and modules for all range of units. To start commercialization, we build and deploy commercial demo. To attract customers, we publish real-time unit performance, input and output data, and video stream to show wave condition, air ducts and chambers. For tourism industry and private customers, we set up underwater camera to show how marine life uses chambers as an artificial reef. On early stages we build, sale and lease small and medium-size units. The large wave mill unit is 200 meters wide and 200 meters long. The generating capacity is up to 100 megawatt. The cost of kilowatt-hour is only 10 cents. We have a plan to build own wave mill fleet to provide power supply services for close to shore areas and for a green hydrogen production.